Welcome everyone, this is your math tutor Naresh. In this tutorial we're going to learn factoring. The first type of common factoring we're going to learn is called common factoring. So before we start working on common factoring, let's just do a simple multiplication first. So what if we are to multiply 5 times, let's say, x minus 3 in brackets? So how do we multiply this out? So we have a multiple of 5, right? So 5 is one factor, and then x minus 3 is another factor. So we're multiplying. Now what this means is that the 5 gets multiplied with each and every term that's inside the bracket. So let's multiply 5 in x. So 5 times x is 5x. And then what about 5 times negative 3? So that is negative 15. So this is how we multiply. Now factoring is the opposite of multiplication. So it's like unmultiplying, that would be factoring. So now what I'm going to do is start with this expression, 5x minus 15. So the question now I'm asking you is, how do we factor 5x minus 15? So that's the question. So factor this. And we already have the answer because we chose to multiply 5 and then x minus 3, and when we multiplied it out, this is what we got. And now we're saying let's just go backwards, right? So we're given 5x minus 15, we factor this, so the question becomes, what are the two factors, or what are the factors of this expression? So the first type of factoring is, whenever you do any type of factoring, the first thing you want to do is always common factor. So we're given two terms, binomial. So is there anything common? So that's what you're looking for. So the first term is 5x, the second term is 15. Now we have 5 and a 15. So does that number, is there a number that goes into both the 5 and 15? Yes, 5 is a multiple of 5 and also 15, right? So we know that 5 is a common factor. So in this question, a number is common, and that number is 5. And you always want to take out the highest number possible. So in this case, the highest number that we can take out is 5. 5 goes into both 5 and into 15. Then you look for the letters. Check out the letters. So we have a variable x in the first term, but there is no variable in the second term. So the variable is not common in both terms. So the only thing that's common here is 5. And now you make set of brackets, and now inside you're going to have the remaining two terms, right? And what's inside the bracket will be our the other factor. So we started with two terms, then we'll end up with two terms. So now you can ask yourself, 5 times what will give me 5x, right? So, and that answer we know is x. We can do this in our head. 5 times x gives me 5x. Now 5 times what will give me 15? So that number is going to be 3, right? So 5 times 3 will give me 15. And then you need to decide on the sign here, whether it's going to be a positive or negative. We want negative 15. So 5 times negative 3 will give us negative 15. So that is negative 3. So 5 is one factor and x minus 3 is the other factor. So what we have done is common factor. So we found what was common in the two terms, we took it out as a factor, and then inside the bracket we found the other factors. In this case there happened to be only one other factor. Now to get this term, what's the other way, or what's the proper way? The proper way is you take your first term, which is 5x, and now you want to divide it by the common factor that you took out. So the common factor was 5, and now simplify this. So 5 over 5, they cancel, and you're left with just an x, and that's how we get x. Okay. Now do the same thing to get the answer here. So take the second term, so that is 15 or negative 15, it doesn't matter. Actually, let's take out the sign because we can worry about the sign afterwards. So 15 divide by the common factor that you took out. So now what's 15 divided by 5 is 3, and that's how we get 3. Okay. So that's a very simple question where a common factor happens to be a number. Can we have letters, the variables, as common factors? Yes, we can. An example of that would be so let's say something like this. If we have let me use complete variables. So if I have ax plus bx. So we're given that question, and let's factor. So you look at both terms and you determine what is common. A appears in the first but doesn't appear in the second term. So A is not common, and similarly B is not common because B appears only in the second term and not in the first. So, but X appears in both terms, right? So X is common. So we can say X is a common factor. Let's take that out, make a set of brackets. And now inside we're going to have two terms. So let's determine what the terms are going to be. So X times what will give me AX? Well, the only missing variable is A. So X times A is XA or AX. They both mean the same thing. And similarly over here, so positive, we're going to have positive there. Now X times what gives me BX, right? And that has to be B. So X times B gives me BX, right? So that's how we get the answer. Now, can we apply the proper way? Yes. So let's take the first term AX and we divide by our common factor, which is X. So the X's cancel out and we're left with A, and that's how we get A. But you don't have to do this every time. This is just a learning process, right? So once you understand the concept, you don't have to do this. If you are in doubt, then you could do this to make sure that you are really writing the right terms in the bracket. Okay. Now let's look at the second term. So the second term here we were given was bx. So divide by the common factor. Common factor is x, and again the x's cancel each other out, and we're left with b, and that's how we get b here, right? The faster way is to think. X times what will give me ax? X times what will give me bx? So that's the faster way. And if you do it this way, that's time consuming. So it's only while you're learning, and if you get something of a complex question, then you may want to do this just to make sure that you're moving forward correctly. All right. So now what I'm going to do is show you 5 different examples where we do common factoring, and then I will do more practice questions. But let's just look at the first 5 questions. So once you grasp these 5 questions, then you'll know how to common factor, and then after that it's just a matter of getting a lot of practice. Okay, so the first question is 5x minus 15y. So let's common factor this. So the process is you look at both terms and you ask yourself what is common. So in this question, 5 and 15, so they're both multiples of 5, so 5 is a common factor, right? So as far as the numbers are concerned, 5 is common. Is any variable common? We have x in the first but not in the second, so x is not common. Y, we have it in the second term but not in the first, so y is also not common in both terms. So the only common factor here is 5. So now let's make a set of brackets. Now determine the remaining 2 terms of the second factor. So 5 times what will give me 5x? 5 times x will give me 5x. And then, so 5 times negative 3 will give me negative 15. And then, but I want 15y, so it's going to be 3y, right? So the question is 5 times what will give me negative 15y. So we go 5 times negative 3y will give us negative 15y. So that's the answer there. So you can always check your answer. So if you wanted to check, all you have to do is you have to multiply. So multiply this answer. So 5 times x minus 3y. Multiplication is easier than factoring because multiplication is moving forward, right? So 5 times x is 5x. 5 times negative 3, negative 15 times y is y. You see? So that's how you can check your answer. So I just want to show you how we got negative 3y by doing the proper way. So you would take your second term, which is 15y from here, divide by the common factor. Common factor was 5, so we go 15 divided by 5 is 3, so that's 3y. And that's how we get that. Okay. All right, so now let's look at example 2. Example 2, we have 16a squared minus 20ab. So here, let's look at the two terms. So we have 16 and we have 20. So let's figure out the number part first. So 2 goes into 16, 2 also goes into 20. But what we want is the largest number, right? So 2 goes into both, then try a higher number, try 4. Does 4 go into 16? Yes. Does 4 also go into 20? Yes. Okay, 8. 8 goes into 16, but doesn't go into 20. How about 10? 10 goes into 20, but not into 16, right? So the highest number here that goes into 16 and 20 is 4, right? And if you chose to factor out, let's say, 2 at this step, and there's nothing wrong with that, you can. It just means that then you'll have to factor further. You will not have factored fully at the first step. That's all it means. Then it means you just got to continue factoring until you factor all the way. Okay, so now let's look at the variables. So let's eliminate b first. B doesn't appear in both, so b is not common. Can't be common. A is common because it appears in both, right? So let's take out a. Now, a has an exponent of 2 here and a 1 here. So you always want to take out the lowest exponent, because when you factor something out, you can only take out something, a variable with the lowest exponent. Okay? If you take out the variable with the largest exponent, then you'll end up with the negative exponents inside the bracket, and we don't want negative exponents. So just remember, for the variable, we always take out the one with the lowest exponent. Okay, so now 16a squared. So 4a times what will give me 16a squared? So 4 times 4 will give me 16. A times a will give me a squared, right? So 4 times 4 is 16. A times a is a squared. So that's correct there. Now let's work with the second term. This is going to be minus, right? 4 times what gives me 20? So 4 times 5. And then a times what will give me a times 1. So a is already there, right? So we don't need anything here for the a. The b just gets multiplied with 5. So that's the answer there, right? So you can double check. So we've already checked the first one. The second, 4 times negative 5 is 20, negative 20. A times b is ab, okay? So that's how we do that one. And that was number 2. And now let's look at number 3. So we have 18m squared n minus 9m squared n squared plus 3m n squared. Okay. So here I'm given a trinomial. Trinomial has 3 terms, right? So, but we're common factoring, right? So we're factoring. So let's look at the number first. We have 18, we have 9, and we have 3. So what's the largest number that goes into 18, 9, and 3? So we have to start with 3, right? 3 goes into 3, it also goes into 9, it also goes into 18. So, right, so I've already found it, it's 3, but you can test it to see if you want to try 9, right? 9 doesn't go into 3, right? So 3 is the largest number that we can take out, okay? So what about the variable m? Does m appear in all three terms? Yes, it does. So it's common. So what's the highest exponent, or sorry, the smallest exponent? This is m squared, that's m squared, that's m to the 1. So I'm going to take out m with the lowest exponent, so that's m to the 1. And now what about n? Does n appear in all three terms? Yes, it does. So it's common in all three terms. And again, I'm going to take out n with the lowest exponent. Lowest exponent here looks like is 1, this is 2, this is 2. So my common factor is 3mn. So now inside my brackets, I'm going to have three terms left, right? So 3 times what gives me 18? 6. M times what will give me m squared? M times m. Remember your exponent rules. When you multiply with same bases, you add the exponents. So n times 1 will give me n, so I'm done because n is already there, right? Now the second term, so 3 times negative 3 will give me negative 9. So m times what will give me m squared? M times m, all right? And then this is n squared, so n times what will give me n squared? N times n will give me n squared, okay? The last term, so 3 times 1 will give me 3, so I don't need to bother writing 1. And then m is already factored out, so I don't need to worry about m. So n times what will give me n squared? N times n will give me n squared, okay? So that's that. Okay, so now let's look at example 4. So example 4 is where I have 5x times a plus 2 minus y times a plus 2. So a common factor here. Now when I common factor here, it looks a complex expression. It doesn't look like there's anything that we can factor, but actually we can. So what's common is we have a plus 2 and we have a plus 2. Notice we still have two terms. I could replace a plus 2 by some variable, let's say z. Then this will become 5xz minus yz, right? Then you see z is common. I can take out z. I'll be left with 5x minus y, and I'm done, right? But it's the same concept. So I don't have to replace this bracket by some other variable. I can just take out the entire bracket as a common factor. Okay. So I'm going to erase this. So common factor is, see, this is one term, this is the second term. So what's common, right? So a number is not common, x is not common, y is not common, because they don't appear in both terms. A plus 2 appears in both terms. So a plus 2 is my factor, and then in the other bracket, what am I left with? So from this, I'm left with 5x. And then from here, once I pull out a factor of a plus 2, I'm left with minus y. So that's the end of that question. So the only thing we wanted to show you here was that, yes, you can have a bracket, which is common. So you probably haven't seen that before, but yes, you can take out a bracket as a common factor. And the last one, so that's 3a times 4a minus b minus 4a minus b. So how do we factor this? So now, again, it looks complex, but actually there is a factor of 1 here, right? Because 1 times anything is that itself. So again, we have a common factor of 4a minus b, the whole bracket. So we take out a factor 4a minus b, and then inside the bracket, so from this term we're left with 3a, and from this term we're left with minus 1. So that's the answer there. So these are the 5 examples I wanted to show you on common factoring, and I hope you found the tutorial useful. If you did, please like or subscribe, and I'm going to do 2 more videos on common factoring where we will do more practice so that you become comfortable with common factoring. Thank you for watching, and we'll see each other in the next video. Once again, thank you for watching.